Good day, everybody. Tom Cryptogram here. I'm back with another video and a set of reviews. Today we're going to be reviewing more advanced projects. Once you've kind of passed up the basics and you feel like you want to jump in and learn something more advanced, where do you go? What do you do? And there are a lot of options. And the first option I'm going to recommend is to find an advanced project that really has a set of lessons and building steps and building blocks that kind of get you up to the point where you're comfortable with that large project. It's going to be a really odd journey, but this is one of my favorite ones right here. This is called Bitwise on the Handmade network, and of course the description or the links will be in the description below as normal. This is a really advanced project, and you can see in the description here, it's a free educational project about building the software and hardware stack for a simple computer from scratch running on an FPGA. And if you just go to the episode guide and check out the Q&A, it's about an hour long. Almost every video, I believe, is an hour or so, between 45 minutes and an hour and 15 minutes. Unfortunately, this project kind of fell off, but I don't know, I wasn't able to follow along long enough because I was so busy at work at the time when this came out about 2 years ago. I had just started my new job maybe 8 months before that, and I was so busy with just trying to learn all of the new things that I needed to do at my new job. I wasn't able to follow along this project. By the time I actually had some time to come back, it had already kind of fallen off. And there are actually a couple more videos after this if you go to the actual YouTube channel. If you click on any of these, clicking YouTube right here will actually take you to YouTube, and then you can click on the channel, subscribe. But Per Vongson, who is taking us through all of this, has definitely dropped off of this project. I believe I actually saw a tweet from him just a couple of months ago when he was talking about going back through some of the old code for this. I don't know that he has any plans to pick the project back up, though, unfortunately. So what I'd like to know is if the project is at a point where if you go through every single step through all 60, I think it's actually 64, 65 videos, if you can complete it, but there is absolutely a ton to learn here. There's just an enormous amount of information that can be learned from building this stack, looking at logic design. If this is a little too advanced, though, we can go something that's a little more introductory if you're looking for something more along the lines of electronics in general. This is a kit that I picked up a while back that came with a CPLD, which is like an FPGA. I really don't know what the differences are, except that I know that a CPLD won't lose its burned-in programming when you program it, when it's powered off. And there are ways, as far as I can understand, to make FPGAs do that or make them reprogram themselves upon being powered back up anyway. But that's besides the point. So CPLD is like an FPGA, but different. If anybody can maybe tell me in one of the comments sections in either Reddit or YouTube what the differences are, that would be great. It really shouldn't matter all that much anyway. I bought this kit here, and I bought actually one of their electronics kits for one of their other sets, and it was okay. If you go to, if you go to the original lesson, I think I'll probably put this in the video, because from here you can just go to one of these down here, the CPLD breakout board, open that up and purchase it if you want. But from here it actually takes you through Blinky and doing different things with their product. I thought this was a very good set of lessons for some real basics. So moving on to something more advanced, of course we've always got Reddit. I'm on here a lot of people are, not that I'm a lot of help, although just recently somebody asked what's the best way to learn Verilog fast, and of course I jumped in with my own information of from my previous videos that I made that I've just kind of all just put this together recently, and got some feedback that was nice, and back and forth I seem to have like more or the same number of upvotes as the actual post itself, so that's been kind of interesting. You don't see that a lot. And from here somebody else actually mentioned a resource that I'd never seen before that I thought was very good, and I'll have a link to this in the description as usual, but it's actually this one. I have the English description, so immediately somebody said no comprende, because it was, if you went directly to this link, it was in Spanish, but there was a translate option, and if if the person had looked, there was actually a like link, when it said this in Spanish, I believe, there was a link that said English version, and if you just clicked on that, again, I'll have a link directly to the English version in my description. And this looked like a really good set of projects and things. This is related to the FPGA Wars, which I've heard of before, but I'm not super familiar with. And FPGA Wars is supposed to be, I think, a set of projects and more advanced things that you can do with FPGAs, and kind of, I don't know what the wars part is with it exactly, if there are challenges and different things. There are lots of different tutorials. It seems very cool. I definitely try and get into this, maybe start here, see how this particular guy said he learned fast with this tutorial. Anyway, I think I can recommend it on the maybe 35 minutes I spent checking out the different sets on GitHub. So speaking of GitHub, GitHub itself is a massive repository of code and different things. If you're not familiar with it, you absolutely should be. It is basically a repository for you and anybody else to create a free login and deposit your code and keep up with it. If you're not familiar with Git as a source code repo, you definitely need to become familiar with it as soon as possible. Speaking of, OpenCores is a similar sort of website for posting advanced projects, and I believe this is all very specifically to do with hardware design, HDL in general, and we can look at all sorts of different stuff here. Video controllers, those are very popular if you're getting into stuff. Oh, an H.264 decoder. So I actually haven't looked at this before, but H.264 is a codec that you probably have. It's built into the chips that you're anything that's going to decode information over the web for streams, video streams like Hulu and Netflix probably all use H.264, and the reason they would use that specific codec is because the chips built into your television, let's say you have a smart TV, are going to have a specifically burned in section of their CPU for decoding this as quickly as possible, because it's a set bit stream. And so when you have this sort of standard that comes up, and you're able to just build that into the chip and say, oh, I see that this is an H.264 instruction over and over and over and over, because it's being streamed in constantly, you can just build that into your chip directly, instead of saying, what is this, decode it, decrypt it, display it. What is this, decode it, decrypt it, display it. You just say, it's H.264, send it through that pipe constantly. So pretty cool way to do things. And so this is, again, like a GitHub, but whereas GitHub is for any type of code. You can post Python, C++, whatever you want, text files, I'm pretty sure all sorts of other things. And whereas OpenCores is specifically for HDL. I'm only mildly familiar with it. I've been through a few projects just to kind of look at them, and so it's definitely a place to go look at if you're looking for something really odd or interesting, or need an example of something and you're not able to find it on GitHub or some other tutorial. After that, we've got FPGA for Fun, super popular, almost a tutorialized set of projects, rather than here's some code because I made X, look at my code for X. I believe it's a little more hand-holdy to take you through all that sort of stuff, whatever you need to be, whatever you're trying to do. Palm game, interesting. So VGA rather, FPGA. I assume there's some interesting information here on maybe the front porch and the back porch, and H-sync and V-sync, of course, all of our standard stuff. So it's going to explain all of that and take you through creating a Pong game. And an HDMI. Everybody wants to learn HDMI. Anyway, after that, one of my favorite all-time YouTube channels for anything electronic related whatsoever is Ben Eater. He also has a website, but actually let's just look at playlists. So he built a couple of different computers from scratch, and you can buy his kits and follow along. I don't think you have to buy the kits at all. He has pretty generic parts, and he keeps it that way. But he's got some videos on why maybe buying cheaper parts and parts from other places aren't as good. So the quality of breadboard alone can be pretty detrimental to your success if you get the wrong ones. And he actually breaks down a good and bad breadboard and shows you the insides and why they're good and bad. But going from that, I'm pretty sure actually with all of the different videos he has here, we should be able to actually look at everything he's done and recreate this in hardware. The problems you're going to have is actually when it comes, so like designing some of these smaller like EEPROMs and things in digital design is going to be a little difficult, especially for a beginner. I haven't done anything like that, but I believe HDL bits. So if you've gone through HDL bits, they'll show you like, oh yeah, this is a common 7458 chip, and it has these inputs and these outputs, and I was able to. So I haven't done it on this computer, unfortunately, but even I was able to look at this even without knowing almost anything, and say, okay, this is what I want to do with each of these inputs and outputs, and this is how I want to make it work, and actually got this working. So yeah, so here's a screenshot that I had where at one point I knew I was going to be moving from computer to computer, and I didn't want to kind of redo all of this, although now I want to as a refresher, so I probably won't use these, but I took screenshots of all of my successful runs with HDL bits. And so yeah, here's my implementation of this 7458 chip right here. There's not a lot to it, and you can see here how almost knowing literally nothing, it really feels like I'm able to complete something. It seems fairly difficult and has some tricks to it, and just having some basic knowledge of C and understanding combinatorial logic between values using ORs and ANDs, I can create this chip and make these inputs and make the correct inputs and outputs. So we should be able to look at an EEPROM that is defined by Ben Eater, find the schematics and recreate that, or find somebody else's implementation online and slam that into our code. I haven't done any sort of project nearly this size, but it seems like a good way to go to me, or at least attempt it. And I feel like there's a lot of learning done in attempting this sort of thing. Getting all these wires together, getting all of these, the outputs. So what you're not going to have on a breadboard, what you're not going to have on your FPGA, that might be a little more difficult, is trying to figure out how the I/O pins want to line up with some of these LEDs or these counters, and you might have to find totally different solutions. This is obviously a lot. Having this sort of output, all of these different LEDs all over the place, are a lot easier to set up on a breadboard, especially when somebody kind of lays it out for you and tells you what to do. And we don't have nearly this many LEDs on any FPGA I've ever seen, so you're going to have to find some more clever ways to do your output like that and make sure everything's working along the way, along with some of the switches and things, and the 7 segments. But there are ways. I showed you in the last video the FPGA I have that had all of the different peripherals that are completely from an Arduino kit, basically, and hooked straight into the I/O pins. And so it's not impossible. You just have to get a little clever with it. But getting clever at our stage is a little difficult because we're so new to all of this. So, well, and then finally we've got, I don't know how to say his name, so we've got Robert here, and I really like his channel. And the thing I would specifically jump on right off the bat is trying to look at how he builds a CPU on an FPGA. Pretty good way to get started, and pretty dead on with what we're trying to do, most likely, depending on exactly what you want to learn and what you want to do with your time. So let me make sure I didn't miss anything else. Alright, so after all that, one of the last places I would definitely look, though it's very last but not least here, would be Hackaday. Hackaday is an aggregate website where you can create a login and set up your projects and show people how you did whatever that you did. Hopefully something a little bit novel and a little bit interesting. But even if it's not, I think it's okay here. And so this person in particular, for this project, created a DIY personal computer built around a 32-bit version of the RISC-V processor. This is the RISC-V, I believe it's called 32i implementation. There's also a 64-bit implementation, if you're familiar with that, ISA, and if you care. So definitely an interesting place to start. And this was a project that I was personally interested in when I started trying to understand how VGA works over FPGA and how to connect the two and everything. This was really, really cool to me. So it's a standalone video card, if you can really call it that. They can, yeah, right, do this 640 by 480 over serial, and I thought this was super neat. I'm very much into graphics and graphics programming. It has a little bit to do with what I used to work on in my career, though I'm a little away from that now. I'm still obviously going to stay in that space largely and probably revolve around it quite a bit. So getting into this level of coding is very personal to me, but you might find it interesting as well. There's just a ton of, so I don't know if I can say enough about this project or about Hackaday in general. You can really just go here and do a search for FPGA and see what people have. Just take a look around, see if there's anything you're interested in. Programming and communication interface for FPGAs. Never heard of it. I haven't seen this project before. You can see how most of the people that create these, just with their own free time, for fun, have a nice description, general details. They tell you what you need to run their project. Their code is typically posted somewhere in like a GitHub with a GitHub link. They'll do updates. I've contacted a couple of different people on through the Hackaday website. You know, you can try and direct message people when you log in and you know, chat with them. And I've had quite a bit of success with getting chats back from people when I ask, like, oh, I think you missed this, or I don't know that, I didn't understand this step, that sort of thing. Usually within 24 to 48 hours, these people that have made these projects years ago will still be very glad to help you and answer your questions. It's fantastic. It's a great community, and I just can't recommend it enough. So I hope you'll learn something today. I hope maybe I enlighten somebody on something somewhere at some time. That would be fantastic. And please, if you have any comments, good or bad, let me know in the comments. I really want a lot of feedback on these videos. And I believe in the next video, we'll kind of review a better, more complete answer to the question, what's the best way to learn Verilog fast? I think we're pretty much there with this answer here, and this is about as good as it gets. But this is you know, the beginner set. This is where you have learned Verilog, but if I've really learned all of the syntax of C++, but I haven't really made that many programs, have I really learned C++? Probably not. I would say absolutely not, and I think any software engineer would. I could know what every keyword does through rote memorization, but can I actually program anything? Highly unlikely, if at all. Again, you know, if you know all of those things and have a ton of experience, that's where you want to be. So I think we'll end with a lesson plan that'll get us there. Thank you all for your time, and have a good day. I'll catch you on hopefully Wednesday with that plan set aside. I do want to do one more video after that as well, just on resources that I wasn't able to ever cover. It's mostly just going to be a bunch of books that I've found that have been highly recommended, but unfortunately I haven't had the time to go through every single book and resource I've ever found, so I'm kind of just throwing stuff at you at that point that I haven't personally vetted and know nearly nothing about, which isn't great, but at that point it's really just throwing more content at you so that you're never at a loss, rather than making sure that the content is necessarily good at this point. So I do think we have enough solid contacts and solid resources, that really shouldn't be a problem. And it's just always we're at a more is better kind of point at that stage. So thank you all again.